Well, welcome to lesson 4 of this Arduino C++ course, and today we're going to start looking at digital pins, specifically outputting from digital pins, and we're going to be turning LEDs on and off using digitalWrite. So up until now we have been just using the serial monitor to output from the Arduino, but as you can see today we're going to break out the breadboard and we're going to install some components. So in the right hand side we have a potentiometer. This is a 10K one, but other values will be fine. I've got two buttons. These both have pull down resistors, and then here we have 8 LEDs, and each of these LEDs has a resistor, and obviously this is all connected to the Arduino. So let's have a look at how the circuit is built up. So as always, there is the resource page. Go over to the Digital Town website, click on lessons, and we are down at lesson 4. Over here we have the circuit diagram. If you click on the circuit diagram, you will get a bigger version. So let's have a look at what is going on. So for those who have never used a breadboard before, let's explain how the breadboard works. You will see that there is a blue line here and a red line. Now that means that all of the holes on the breadboard in this line, we tend to use those as a positive connection, that is connected to, in this case, the 5 volts. The other line of pins we treat as being connected to the ground. Now on this circuit that I have built up today, I'm not using these 2 rails, but I am using the top 2 rails. So you can see that my 5 volt connection comes out, goes across to this top rail, and once it has put the power into this top rail, all of these other components can take their 5 volt feed from it. And in the same way with the ground connection, we can see that the potentiometer here is taking a ground connection. These 2 resistors are connected to ground, and one leg of all of these LEDs is connected to ground. So the rails next to the red and the blue line on both sides of the board, all the connections going across are connected to each other. Now, just as a word of caution, going back to the breadboard, on this breadboard here, this has got another project that I'm working on mounted to it, you'll notice that the red line goes the whole length of the board, the blue line goes the whole length of the board. Unfortunately, the breadboard that I'm using at the moment, you'll notice there is a gap, and I have put 2 pieces of wire between the gap. If you've got this breadboard, then just as on the diagram, the power goes the whole length of the breadboard. If you've got one where there is the gap in the red and again in the blue, it means the power is shared along this side and this side, but this side is not connected to this side. What I'd advise you to do is just put a piece of wire across, or one of your connectors across if you've got spare ones, because it can really cause you some problems. I wanted to get the power out onto this rail, and of course if I don't have those connections in, the power goes one way but it doesn't go the other way. So if you've got a board with the breaks, just be aware that you're going to need something to connect across to make the power go the whole way. So coming back to our circuit diagram, the way the breadboard works, these pins here, these little holes, they are connected to each other. These are connected to each other, but there is a gap between these pins and these pins. If you like, this trough that goes down the middle of the breadboard is an insulation between this side and this side. So that means you can put a component like this resistor across the center gap, and obviously this pin is not connected to this pin. Now, the way we are going to work today, we're going to be using LEDs. And one of the problems is with LEDs, they're not like a old-fashioned sort of light bulb that you could put the power through in either direction. They take the power in a specific direction. So if you look at this LED, most LEDs, when you pick them up, in fact all LEDs, when you pick them up, you will see that one leg is longer than the other. Now, on the diagram, the long leg is symbolized by this sort of kink in the leg. The long leg always goes to the positive connection. The short leg, the straight leg in the diagram, goes to ground. So on this circuit, this rail here is ground. So if you like, these are the shorter legs, all going into their ground connections. The longer leg is going towards the positive connection, which in our case is the power that is going to be supplied by the Arduino. Now, the reason for this resistor, I have used 330 ohm resistors, is because our Arduino puts 5 volts out, and an LED is not a 5 volt item. They are less than 3.3 volts. They're a bit of an odd item depending on which color. They have different voltages, but if you put a 330 ohm resistor in, then you will be fine. So you can put the LED across the center and the resistor to ground, or you can put the circuit as I've put it. It's up to you. There's no order for the LED and resistor, but between the power supply from the Uno and ground, there must be the LED with the leg facing the correct direction. If you like, the long leg faces the Arduino, and there must be a resistor. Now, it is this section that we're going to be dealing with today, so I will explain more about the other end of the circuit as we get to look at buttons and the variable potentiometer. Just so you know, the resistors that are in this circuit are 4.5k to 10k resistors, and when you look at the circuit, you will see that there is one connection from the button here that goes to this wire and to the end of this resistor. But if you're a bit confused, just don't build this part of the circuit for now, and you can put it in the next lesson. So today we're going to focus on these LEDs. Now, the other part of this lesson is we're going to be focusing not just on the LEDs, but on digital pins. On your Arduino, if you look, the digital pins are numbered from 0 up to 13. Now, we are not going to use pins 0 and 1. If you look carefully, you will see RxD and TXD, and if you notice, TX and RX, those are the two LEDs that flash when you put your code into your Arduino. So that is the communication via the COM port from your computer, sending data over TX and RX. Now, if you plug components into these two pins, you can have some problems with your code failing to upload because the items that you've put in here cause some confusion. So that's the reason that I have not put any components in there. Going along though, the rest of the pins 2 to 12 are just normal pins. Pin 13 is an odd one. You can use it, there's not a problem, but when you do use it, you will see that there is a built-in LED, and that will also come on when you output from this pin. Now, on the other side of the board, there are some pins down the bottom. These are called analog pins, and you can see I've connected one to the potentiometer. The difference between these pins is that an analog pin will read a value between 0 and 1023, whereas the digital pin deals with 0 or 1. So from an output point of view, 0 means it's turned off, 1 means it's turned on and will supply 5 volts. When we are reading from buttons, 0 means no signal is being received, 1 means it has sensed a voltage on the line and therefore it is receiving something. So digital pins are 0 and 1, whereas analog pins vary over a range of values. So if you're going to follow along and build the circuit, at least try and put in these resistors and LEDs for now. So now we've looked at the circuit, let's start to look at the code. So today we're going to start with a brand new sketch. I've called it creatively Lesson 4. We're going to be using digital pins for outputs, and we're going to learn 2 functions. We're going to learn pinMode and digitalWrite. Now, the next bit here that I've put in, this is something that I would advise you to do as you build your projects. You'll notice I have listed all of the pins that are being used. Now, when we come to this first pin, analog 0, that is the way that you list, if you like, an analog pin. You'll notice they are A0, A1, A2, A3, A4, A5. So although I'm not going to use this item in this lesson, neither am I going to use these buttons, because I've connected something to them, I have listed them, if you like, in my list of pins that I used. And then I've also listed all of the digital pins we're using. Now, again, I could just list the pin numbers and put LED, but if you like, I've tried to explain which LED it is. So from my point of view, as I look at the circuit, I'm saying that this is the right blue LED, this is the right hand red, right hand yellow, right hand green, then of course left, left, left and left. So that is what all of these things are, and it's just a good habit to get into. So let's now go down to how we control our first LED. Now, as usual, I've started the serial monitor and I'm going to serial print out lesson 4. We're not going to worry too much about the serial monitor today, but it just means if I was to pick up this Arduino board in 2 weeks time, 3 weeks time, when I've forgotten what's on it, I can just check on the serial monitor and go, right, that is the code from lesson 4. So here are the 2 functions that we need to use. Now, going up to the reference, again, the reference here is your friend. Bringing up the reference, the 2 functions that we are using is pinMode and digitalWrite. Now, when I talk about a function is, if you like, some code that someone else has written. So there may be all sorts of things going on in the background, but we just, if you like, connect to this function and it either does something or it gives us a result or it sets something up for us. In our case, we're just going to get these items first to set something up for us, and the pin, if you like, the LED pin that I'm going to start with is this one here, left green LED. So that's the one right at the end of the line. So the pin mode, the first thing it does is it takes the pin number, the digital pin number, and then we're going to put in output. That is because we are using the pin to control something. If we were connecting to a button where we're trying to read a signal from outside, then this would be changed to input. Now, if you notice, I'm going to put my mouse pointer over the word output, and you will see that the definition for output is 0x1. Now that is the hexadecimal value for 1. So I could change this line. I make a copy of it here. I could write this line like that, and it would do exactly the same thing. The problem is it's not very, if you like, human readable. So it's much better to use the definition output. The next line actually sends the control message to pin 12. So it now knows pin 12 is set up to receive an output. It's going to send something out. Basically, it's going to go on or off, high or low, and we are going to send the value high. Now again, I've put the mouse pointer over so that you can see that the definition of high is 1. So again, I could write this line of code just like that. So it would become digital pin 12, send it high with a value of 1. Now, although you will virtually always use output when you are using pin mode, it is very common to use the value 1 or 0. So high is 1. If we put low in there, it would be 0, but it's quite common to put 0 or 1 when you are digital writing something, because that is an easier way to output a variable. But for now, we're just going to leave it with that word high. So I've uploaded the code. I'm just going to press the reset button so you can see the serial monitor output, and of course the LED switching on. So that is setting the pin high. So now that we have our LED turned on, the question is, how do we turn it off? So what we're going to do is we're going to make the LED blink on and off. And to do this, we're going to reuse some of the code that we learnt in lesson 3. We're going to use exactly the same timer circuit, except this time we're going to be using it for turning LEDs on and off. Now, before we even start to control the LED, let's just clear this up a bit. Just using the pin number is not really helpful. So we're going to set up a variable, and we're going to call it an integer again, and I'm going to give it the name left green LED equals 12. That is a good descriptive name. Now you'll notice the method that I've used. It's sort of traditional when you're writing your variables that the first word is lowercase and then every other word is uppercase. When you're creating a variable, you cannot start with a number. That does not work. The other thing to remember is that your variable is case sensitive, so that is not the same as that. Those will be two completely different variables. So we're going to call this the left green LED, and that means now that in our code, rather than using 12, we can just put left green LED in. And now if I put my mouse over that variable left green LED, you will see that the Arduino IDE, if you like, brings up some information. It gives us the variable name, it gives us the type, and it gives me the value equals 12, or the hexadecimal for 12, which is C. So the next thing we need to do is add our timing variables. So we're going to put in our unsigned long, current millis. We're going to put another unsigned long, and we will call this one left green millis. Again, keeping that name, if you like, linked to the item that it's going to control. And then we will put in another integer and we will call it left green timer. And we will give that a value of 1000 because we're going to blink the LED once a second. Just realized a bit of a spelling mistake there. There we go. Left green timer. Now I'm going to show you one of the tricks that I often use when I'm writing my code. Once I've declared these variables, I will very often just copy them, Control C, and then I will bring them down here above the loop and just comment them out. And the reason is it then allows me to very quickly copy and paste the names in, and it means that I'm guaranteed to spell them correctly. So the first item is current millis. And if you remember from our last lesson, we put this at the top of the loop and it equals millis. It calls that function that tells us the number of milliseconds since the board started. Then we've had that if statement. So if current millis minus, and then we've got left green millis is greater or equal to the left green timer, then if you remember, the first thing we had to do was reset the value of the timer to the value of current millis. And we are going to turn our LED on. So I'm going to take that out of there and I'm going to paste it down here. So that means every 1 second it's going to turn the LED on. So let's upload the code and see how it works. So the code is uploaded. And we can see that the green LED is on, but obviously it's not flashing on and off. Now, obviously at this point, I know the reason that it's not turning on and off, but this is the time, if you like, if you were building a project, sometimes you can build something and you think, well, what is going on? Why isn't this working? Is my timer working? Well, at this point, this is where you can use your serial monitor. So we can go serial print line, and the value that we're going to put in is left green millis. Now, by doing this, it checks that the timer is actually running at the correct rate. So let's upload the code. We can now see in the serial monitor that we are getting the correct output. We are seeing, if you like, that we have got 1000 millisecond gaps. That's 1 second gap, so that we know that our timer circuit is working. So the issue is, why is it high? Why is it never going off? Well, the reason is quite simple. Every time this if function runs, it turns the LED on, but we never turn the LED off. So now we have to work out a way of turning off the LED. Now, the code to turn off the LED is quite simple. all we have to do is change the high to a low. However, here is the problem. How do we know the last value of the LED? Are we going to set it high, which if I put my mouse over is a 1, or do I set it low? How do I know when the statement runs which way I need to set the LED? And this is where we need to start recording the state of the LED. So to record the state, we need another variable. And the variable that we're going to use this time is a brand new one. It's called a byte. And we're going to call it the left green state. And this is going to keep track of the state. Now, a byte stores a value between 0 and 255. The reason I'm using a byte is that we're only going to store a 0 or a 1 on or off. And it's therefore appropriate to use, if you like, the box that is best suited for storing that smaller value. Now, there is another value that will store literally 0 or 1, but using a byte for now will be easier. So let's use this variable, and we'll just copy it down so that we make sure that it is spelt correctly. Comment that one out. So this time we're going to use another if statement. So let's imagine our timer is working fine. We know that because if we just move this serial print to here, we know that, if you like, at this point the timer is working correctly. We can see it moving up here, but we need to work out what to do with the LED. So what we're going to do now, we're going to write another if statement. We're going to say if left green state is greater than 0, okay, what are we doing here? So this variable left green state, it's got a value between 0 and 255. What is the current value? Well, when the program starts, it's going to have a value of 0. If it's got a value greater than 0, remember when we put our mouse over high, it's got a value of 1. Low has a value of 0. So if left green state is greater than 0, we're going to make it 0. Now we're going to do something that we haven't seen with an if statement before. We're going to add an else. So this is where, if you like, we're making a decision based on some information. If this condition is true, then it runs the code. With an else statement, there is, if the condition is met, then do this, but if the condition isn't met, do the else, do something else. So what we're going to do there is we're going to say we will set left green state to 1. Okay, so if the value is greater than 0, set it to 0. If the value is not greater than 0, set it to 1, because that means that next time this if statement triggers, this will be a 1, therefore, the green state will be 1, therefore it will be greater than 0, and it will reset it to 0. Now we're going to get rid of one of these lines, and instead of putting high or low, we're going to replace it with the state. So at this point, the value high or low, which is represented by a 1 or a 0, is going to be set by this couple of lines here. So let's upload the code and see how it works. And there we go. In the serial monitor, we can see once a second the function is triggering, if you like, the if statement is becoming true. And we can see then that the first time, if it is greater than 0, it's setting it to 0. If it's not greater than 0, it's setting it to 1. And then it is giving that value to our digitalWrite, and that is controlling the flashing of the left green LED. Now, you will get people say, well, why don't you just use the blink sketch, and we could have just blinked this using delay. But if you remember back to our diagram that we used to explain how everything works, let's just bring that up and move the camera out of the way. If we use delay, the loop is going to stop running. At the moment, we're controlling an LED using a timer. We're sending out an output once a second, but the loop is still running. Now that means that all of the other LEDs that we have can be controlled in a completely separate way, and none of the LEDs code will block any of the other LEDs code. Now I've added some comments into the code. I'm going to get rid of this to make it a little bit clearer. And what I tend to do once I have the code running like this, and I know it's all working correctly, what I will tend to do is comment out the serial print statement because it's not required anymore. Now, serial print uses up a small amount of time, not much, but by commenting it out, I know this area of code is running correctly. So now I can leave, if you like, my serial print statements for later on for debugging something else. Now at this point, we've got our green LED flashing away, but we built a circuit that has 8 LEDs. So I think it's time to start controlling some of those other LEDs. So the LEDs that I have chosen to control are the red LEDs. And as a lot of the projects I do are to do with model railways, I'm going to set up some flashing red LEDs as if they were on a level crossing. Now, on a level crossing, one LED is on while the other LED is off, and they swap over. So this time, when I've set up my variables, I've set up the 2 variables for the pins, because from my descriptions up here, I know that the left red LED is pin 10, whereas the right red LED is pin 6. So I've created those variables. This time I've created another unsigned long, but I'm just calling it red millis. I only need one timer, so although one switch is on and one switch is off, they do so at exactly the same time, so we only need the one timer. I'm going to set the timer for every half a second, and we're going to store the state in another byte, and we're going to call it red state. Now, to save you watching me typing all of this out, I have set the pin modes up already. So we've got right red LED, left red LED, and both of them have been set to an output. And once again, coming down to the code, we're going to leave the green flashing LED as it is. But moving down, we're now going to do our red flashing LEDs. So I have set this up in exactly the same way as the timer was before. You're going to see this code over and over. So we've got current millis minus red millis is greater or equal to the red timer. Check if the condition is met. If it is, red millis now equals current millis, and it will be good at this point to make sure that is working by doing a serial print line, and we will let it print out the value of red millis. Now if we upload that code, wait patiently, there we go, and we're now seeing 500 millisecond intervals for the output. So we know, if you like, that the timer is working correctly. Now you will notice in the code that just like in the previous one where we were changing the value of left green state, I am changing the value of red state. However, this time we cannot use the same system as I did here, and that is because one of the LEDs needs to be the same value as red state. One of them needs to be the opposite. So to get around that problem, all I need to do is do my digitalWrite, and he says looking at the value that is going to be the right LED, and I'm going to send that high. And then when the state is the opposite way, I'm going to send it low. And then I'm going to copy this line and put it in there. And I'm going to put the left LED. And then copy that line into there. And I'm going to put the left LED in there. So now we're keeping track of the state, but we're not using the state to set the conditions of the LED. We're doing that with a couple of other lines of code instead. So let's upload that and see what it does to our LEDs. There we go. We still have our green flashing LED, but I now have my two red LEDs alternating their flashing sequence. So now everything is working as it should. We're going to end the lesson for today, and what I'm going to set you, if you like, for some homework. There are 5 other LEDs up here that need to be doing something. So what I'd say to you is, have an experiment, set those up on some other timings, turn multiple LEDs on together, turn multiple LEDs off together, make them alternate. Have a go at using this sort of code that we've got set up here. Get used to using the timer code, get used to using the idea of setting states, whether you're going to use it in this method or the method that we saw with the green LED. So just have an experiment and see how you get on. And of course, in the next lesson, we should be looking at a little bit more of this circuit, because we need to start looking now at how we deal with inputs. So we shall be looking at those buttons. So have a go at messing around with the other LEDs, and I'll see you in the next video. Bye for now.